Okay, in question 5, we're being asked to do force identification. In force identification, we circle the object of interest and label any forces with symbols: normal force, static friction force, kinetic friction force, weight, tension, drag, before filling in the table. So we're told that the force acts on the child. We're told that there's 3 things that we want. We want to identify the type of the force, the agent of the force. So in force identification, we start by circling the object. This object here is the child. And we ask, well, what are things that are touching this child? Well, one thing that's touching the child is the sled. And the sled is stopping the child from accelerating through the hill, and so that's a normal force. The sled is presumably moving down the hill, and that's presumably something that the child is doing as well. And so the child has got some force of friction between themselves and the sled. We can assume that the sled is stationary relative to the child, so there's going to be a static force of friction here as well. But the child is also being attracted by the earth, and so there's the weight of the child as well. So let's write out what the names of each of these forces are in the table. I don't want to include drag because drag is a force that we'll consider only if it explicitly says in the problem, or if it's obvious that something's going at constant velocity and there's no other force possible that could cause that. So it would be possible to put drag in principle, but it's not as important as these other 3 forces. So names of the forces, we've got the normal force. The child is staying stationary on the sled relative to the sled, so we've got the static friction force. And we've got the weight. The normal force is contact force. And the agent of the force is the sled. The static friction is another contact force, also an interaction between the sled and the child. And the weight is a long-range force. And that's between the earth and the child.